So, you're prepping for an IT certification like the CompTIA A+, and you know networking can be a real beast. Well, today we're going to tame two of its most crucial protocols, TCP and UDP. Let's jump right in.
All right, here's the game plan. We'll start with the two basic ways data gets sent. Then we'll dive deep into TCP and its super reliable handshake, and contrast that with UDP's need for speed. After that, we'll see where they're used in the real world and wrap it all up with a practice exam question to make sure this stuff really sticks.
Okay, so think about this for a second. Have you ever wondered why a web page has to load absolutely perfectly? You know, every single pixel in its place, but when you're on a video call, it can stutter or glitch for a moment and the world doesn't end? The answer to that question is all about the two protocols we're about to unpack.
And that question right there, it gets us right to the heart of the matter. See, the internet really has two main ways of getting information from point A to point B. And honestly, their approaches could not be more different.
So, let's meet our two main characters in this story. On one side, you've got TCP. Think of TCP as the reliable, orderly communicator, the one who checks and double-checks everything. Then on the other side, you've got UDP, the fast and efficient messenger, kind of the speed demon who's just all about getting there as fast as possible.
So first up, let's talk about TCP. Its whole personality, its entire reason for being is built on one single idea: reliability. It is absolutely obsessed with making sure every single little packet of data shows up at its destination perfectly intact and in the correct order.
So how does it pull this off? Well, TCP is what we call connection-oriented. It won't send a single byte of data until it has established a formal, stable connection. It's kind of like making a phone call, right? You dial, you wait for the other person to pick up and say hello, and only then do you start talking.
And that connection is made using the famous three-way handshake. It works like this. Your computer, the client, sends out a SYN packet, which is basically saying, "Hey, you there, can we talk?" The server gets it and sends back a SYN ACK, which means, "Yep, I hear you, and I'm ready to talk too." Then your computer sends one last ACK packet, saying, "Awesome, conversation started."
And this is what you get at the end of that little dance. The connection status is now officially established. Only after this digital handshake is totally complete will TCP even think about sending the actual data. The line is now open and secure.
All right, now let's flip the script and talk about UDP. It is the complete opposite. If TCP is that carefully placed phone call, UDP is more like sending a postcard. You just write it, drop it in the mail, and kind of hope for the best.
You see, UDP is connectionless. There's no handshake, no how do you do, no formalities whatsoever. It just fires the data out there. Now this makes it incredibly fast because there's almost no overhead, but here's the catch. There are zero guarantees, and I mean zero. Packets can get lost, they can show up out of order, and UDP frankly just does not care.
A perfect example of UDP in the wild is DHCP, which is how your computer grabs an IP address. It uses a quick four-step process we call DORA. First, your device broadcasts a discover message, basically yelling, "Hey everyone, I need an IP address." Any available DHCP servers on the network respond with an offer, saying, "Hey, I've got one you can use." Your device picks one and sends a request, "I'll take that one, please." And finally, the server sends back an accept, saying, "You got it, it's all yours." It's super fast, super efficient, just perfect for UDP.
So, you've got the careful, reliable planner on one side and the super fast messenger on the other. Now let's put them side by side and see where you'd actually use one versus the other.
And really, it all comes down to this one fundamental trade-off. TCP gives you that high reliability, that guaranteed delivery, but all that checking and acknowledging adds overhead, which makes it a bit slower. UDP, on the other hand, is all about being connectionless and fast, but it does that by sacrificing any and all guarantees. You're basically choosing between perfection and pure speed.
And that choice, it really changes everything. You use TCP for things that absolutely positively have to be perfect. Think about loading a secure website with HTTPS, or downloading a file with FTP, or sending an email. You can't have missing bits and pieces there. But then you have UDP, which is the undisputed champion for real-time stuff like voice calls, live streaming, or online gaming, where a tiny momentary glitch is way, way better than a long, awkward pause.
All right, theory's great, but let's get our hands dirty. We're going to walk through a performance-based question, the exact kind of thing you're likely to bump into on your CompTIA A+ exam.
So, picture this.
You're looking at a network capture tool, and it's showing you a bunch of packets. Your task is to figure out the right sequence to successfully establish a connection and load a web page. You ready?
And here are the puzzle pieces you've got: a GET packet, an ACK, a SYN-ACK, and a SYN. Now, based on everything we've just talked about, what has to be the very first step in this chain?
If you're thinking SYN, you are spot on. It always starts with the client kicking things off, sending that synchronized packet to get the server's attention.
Okay, step 1 is done. What comes next? Well, the server has to answer back, right? It acknowledges the client's sign and sends its own sign back. That's our SYN-ACK packet.
And finally, to close the loop on that three-way handshake, the client sends one final acknowledgement, the ACK packet. Boom. The connection is now established and ready for business.
And now, only after that rock-solid connection is built can the client actually ask for what it wants. In this case, the web page data. And that is our GET request. It's the whole reason for this conversation, but it could only happen after the handshake was complete.
And that's the key takeaway right there. The actual work of the internet, requests like GET to see a page or POST to submit a form, that stuff only happens after TCP has done its job and built that reliable foundation. The handshake comes first, always.
So you see, it's never really about which one is better. It's always about choosing the right tool for the job. So as you continue studying, just keep asking yourself that one question: does this thing need perfection, or does it just need to be fast? Nailing that trade-off is what networking is all about. Keep that in mind, and you'll do great on your exams.